Hello everyone, this is Baha. Today I'm going to show the reasons why Numpy array is faster than list in Python. There are 5 main reasons for that, which are memory efficiency, vectorized operations, optimized algorithms, cache optimization, and parallel computing. So let us discuss all these reasons. First reason is memory efficiency. Numpy arrays are homogeneous, meaning that all elements in the array must be on the same data type, which allows for more efficient memory storage and retrieval compared to lists, which can contain elements of different data types. Numpy arrays also have fixed size and shape, which allows for more efficient memory allocation and access compared to lists, which can dynamically grow or shrink in the size. Another reason is vectorized operations. NumPy provides a large collection of built-in functions and methods for performing mathematical operations on arrays, which are optimized for performance. These operations are implemented in C and Fortran and are designed to work efficiently with the large arrays of data, making use of low-level optimization and hardware-specific instructions. This allows for efficient element-wise operations, array broadcasting, and other vectorized operations, which can significantly speed up computations compared to using loops on lists. Also, optimized algorithms, one of the reasons why NumPy array faster than lists. So NumPy includes many optimized algorithms for tasks such as sorting, searching, and linear algebra, which are implemented in C and Fortran for maximum performance. These optimized algorithms are designed to work efficiently with arrays, taking advantage of the array's structure and memory layout, and can outperform equivalent implementations using lists and built-in Python functions. Another reason for why NumPy array is faster than list is that NumPy arrays are stored in contiguous blocks of memory, which can improve cache locality and reduce memory access time, leading to better performance. In contrast, lists in Python can be scattered in memory, leading to more cache misses and slower access times. Another reason is parallel computing. NumPy provides support for parallel computing using tools like OpenMP, allowing for efficient utilization of multi-core processors and GPUs, which can significantly speed up computations for large datasets. Overall, NumPy is designed to provide efficient numerical computations with arrays optimized for performance and memory efficiency, making it a popular choice for scientific computing, data analysis, and machine learning tasks in Python. Thank you for watching this video and see you in another video. Bye.